Oh, here we go. Oops, sorry, let me turn that off. Day 2. Coronavirus 1, day 2. Here we go. Wait a minute, let me do that again. Cool if we could do an online Kahoot game. Alright, let's look at, I'll try to make this quick. I know sometimes you sit there and it's monotonous, but if you'll follow me, I'll try to get through this one pretty quick. If I can get my bearings straight here. Let's see. Okay. Which value for M makes the inequality true? Notice your answer choices. They look a little bit weird, probably a little intimidating. Here's the inequality. Since it doesn't have like M is greater than or equal to and all that mess, I know I'm going to end up graphing trying to figure out what goes where, okay? First thing I need to do, though, is get this written down, and let's solve. So we got 7 is less than or equal to 9 plus my variable of M over 2. Got to get rid of my 9 first, trying to get that M by itself. And over here, using the handy dandy calculator, got a -2. Those cancel, and I still have left my variable divided by 2. Should have left me some room over here. Might make a mess. Anyway, now I know that I have got to multiply by 2 over 1 here. And let's just put 2 right there. Okay? Make sure I got that problem written down. There are no negatives, so it doesn't look like the only thing we might need to flip is at the end before we graph. Okay, so no flipping going on here. We got... And remember, this might be confusing. You say, well, we're dividing or multiplying by negative. This is a number we're multiplying by on both sides, okay? This was already here. So this is a -4. There is no flip. Less than or equal to. Those cancel. They equal 1. So 1 times M is just M. Now, I don't want to graph like that. So I'm going to go ahead and pop my M over here. Do a little flip of the inequality. Now I got M is greater than or equal to -4. And I'm going to go ahead and graph this right here. So I make sure I get the correct answer going on. Got a -4. Don't forget your negatives run the opposite as the positives. And a -3. And that's a closed circle on that -4. Shaded to the right. So anything that's in my shaded region is a solution. Let's go up here and look. Alright, so it looks like my first one, because the -2 is going to be up here. I think that's it. Let's double check the rest. -4 2/3, that's a little bit past -4. So that's right in here. It's not in the shaded area. -8, way down there. And -5 way down there, a little bit past that 5. So we know we can eliminate all those answer choices by knowing where they are on the number line. And there's our correct answer. Okay? Slide over here. Remember, you can pause these things if I go too fast. The only bad thing is you can speed them up if I go too slow, but don't speed them up too much. It says write an equation, meaning we got to have an equal sign, to match each table. Now, if you struggle with this, go to Google, type in printable coordinate plane or something, and you can print out some graph paper. Sometimes they have like 4 per page like I gave you in class. Print some of that out and graph this stuff if you struggle with it. I'm going to concentrate and focus on finding the rule for each one of these. Okay? This one looks pretty simple. Getting to 3 to 4 doesn't look like multiplications happening here. I mean, you could by a decimal or something, by a whole number like 1 point something. Doesn't look like it's happening though, because when I go through everything like this, 0 plus 1, 6 plus 1, 3 plus 1, -1 plus 1, -3 plus 1, and I put all those in a calculator, I know that my rule is plus 1. The next thing that's got to come to my mind is I got to understand what type of relationship we got going on here between the x and the y, which is additive. And we know that our equation in Math 7 here, this is what our curriculum takes us through, is y equals x plus b. Okay? We know that our rule takes care of the plus b part, which is actually the y-intercept of this line. So we're going to write this equation as y equals x plus 1. Okay? Just make sure that you double check, and I'll write that here. I'm not going to write it for each one. Don't want to waste your time. Let's go over here and look at this next one. I'm starting to think, okay, I could possibly, I don't know, maybe that's, well, if I subtracted, no, that doesn't look good. If I multiply, oh, I recognize that could be 3 times 2. 0 times 2, that works. And then 1 times 2. Now let's check our negatives. Negative 1 times 2. Looks like our rule is going to be times, and I'll put a dot, 2. Okay? First thing to think about, this thing is proportional. So we know it's going to look like this. And we know that this is slope, rise over run. Here's our rule, so we know that the rule takes the place of the m, which the equation is y equals 2x. Okay? Over to the next one. I'm noticing like the difference of 1 between these. Especially the positives, a lot easier to see. 8 minus 1, 7 minus 1, 3 minus 1, 5 minus 1. And then if I check my calculator in case I'm a little weary, negative 3 minus 1 is negative 4. So feel really good about my rule being minus 1 or add a negative 1 plus a negative 1. Either way you want to say it. I know that this is additive, which I know it's got to look like this. And you know, sometimes I think we should write that as plus or minus b. Either way, it's good to go. Some of you are going to want to write this as y equals x plus a negative 1. And that's fine as long as you're able to recognize that that is the exact same thing as y equals x minus 1. Good. Slide over here. Let's go through here. I think this one's a little tough in my opinion. Notice it says no calculator. We got identify each number greater than, I think that's the key, greater than 5, 6. So first thing I'm going to do is get my 5, 6 written here. I got to get that in some kind of form where I can compare that with everything else, okay? So my 5, 6, I think I got room. Look, we didn't use much of this over here, so I'm taking this bad boy right here. And I'm going to at least, I think that's going to run on for a while. I'm going to at least get me a couple decimal places. Ooh, look what I'm trying to do here. Not good. Top dog in the house. 6 goes into 5 0 times, so we're popping decimals everywhere. Popping a 0. And let's see, how many times will 6 go into 50? 8 times 5 is 40. 8 times 6 would be 48. So I'm going to do my 8, 48, subtract, got a 2. I'm going to go one more place and see what's happening here just to make sure. That's a 3. 18. Look what's happening. This 2, remainder of 2, is going to continue forever and ever and ever. So we can put a line over that 3. We got a 83 hundredths with a repeating 3. So let's go here. And let's pop this decimal. Sluggish, ate too many Oreos yesterday. All right, now let's start comparing. There's 6 of them to compare. So what I think I'm going to do is I'm going to put me a line right here. That way I know I'm comparing everything to that Bad Johnson right there. And I'm looking for numbers that are greater than this. I want numbers that are greater than that. 0.83 right there. Let's look at the first one. 0.8, okay? I don't need to go over here and write 0.8 and then write 0.8 again, so I'm going to save a little time. And then I'm going to put a 0. Is this greater than that? Nope. Pop me another equal sign here. What have I got? 1.4. Well, we are way too smart for that one because it's already got a whole number. We know that that is greater. 8.9, really? I must have wrote these. These are too easy. Check mark here. Got an 8. Got a 0 there. Okay, so that one is greater than. Remember, we're looking for greater than that. 11 over 9. Now we got some work. Oops, that 11 looks terrible. Sorry. All right, that's another division thing. I'm going back up here. 11 over 9. 9 goes into 11. Wait a minute. That's improper. So I know that that's going to have a whole number there. Do I even need to go any farther than that? If it's got a whole number, then we know it's bigger than a proper fraction. Don't really have to work this out. I'll tell you that this is 1 with a repeating 2. 9 goes in 11 one time with 2 left over, 1 and 2 ninths. Anything over 9 is going to repeat with that numerator. So we know that that is greater because it has that whole number to begin with. Cool. On the next one, we got a little bit of work here. We got 0.9%. That's a Dr. Pepper. That ends up being 1, 2, bam, 0.009. Well, I know there's no way that's bigger. And then my last one is 84%. Probably I ought to be careful with this one. 84%. Dr. Pepper, 1, 2, bam. 0.84 with a 0 in front. Let's look. Is this bigger than that? Yeah, by 1/100th. So, means it is bigger. All right, let's ride over to the next one. I feel like I'm taking too long. I'll try to hurry. Inequality, which is a value for A that makes the following true. There's our A. Look at this. I know right now I'm probably going to graph to try to find this bad boy. Looking at this, variable's on the correct side to compare, but I see a -3 here with my variable. That's a cause for a flip, so I'm going to be very careful. Let me get this wrote down real fast. I got A divided by -3 minus 1 is greater than 4. Okay, I'm going to add 1. Add 1. Gone. A divided by -3 greater than 5 now. Okay, multiplying opposite of division by a negative number on both sides. Calls for a big fat flip. Go ahead and do that before I forget. These equal 1, and A is less than -15. Well, what does it mean to be less than -15? -15, -16, -14, and I'm an open circle, and I'm shading myself to the left. Okay. Good deal. Up. Better look at some choices here. Oh, it's easy. Look what's in the excuse me, the shaded area. One of our answer choices right there. Good deal. All right, let's go over here. Got Miss Hawks. She got 48 pencils. Gosh, she got more than I got, that's for sure. She plans to give a half to Miss Shoop, a third to Miss Tignor, and 1/8 to Miss Campbell. How many does she have left? Whew. All right, we got to figure out. Here's what we start with. We got to figure out what that amount of that is, what that amount of that is, and what that amount of that is. And then since it's asking for half left, we got to subtract all that from the original amount. I said the word of like 3 times, so I know we got to multiply some stuff. Okay? Now be careful. Desmos or your calculator will take care of this, because I see one of those fractions that's a repeating decimal, and we don't want to pop that decimal in. Let's write the first one as a decimal, though, because we're trying to find half, or 0.5 of, which means to multiply, 48. Half of 48, we probably do that in our head, 24, right? Okay. Then the next one is 1/3, so I'm putting that thing as a fraction. I am not dealing with that repeating decimal. Okay, I pop 1 divided by 3 in my calculator, then multiply it by 48. Or I can do it in Desmos. It'll give it to me really easy. And when I do that, I end up with 16. Then the 1/8. to be honest with you, I know that eighth is 0.125. I can change it to a decimal and multiply it, or I can leave it as 1 divided by 8 times 48. Doesn't matter. Whichever way you want to do it's cool. When I do that in my calculator, I end up with 6. Now, check these out. These are all the pencils that she gave out to the other teachers, right? So let's add those bad boys up. 24 and 16 is 40 plus 46. Check it on your calculator. Tell me if I'm messing up. She gave out 46 pencils. How many did she start with? 48. Good Lord. Now this is what I've got left. Like 2 out of the 800 that we've used this year already. Or should I say 8,000. Okay. 2 pencils left. Good deal. Let's keep going. Subway is having a sale. Buy 2 $5 subs and get 1 free. How much will it cost to buy 12 subs? Look, there's a typo. That should be B-U-Y. That's probably my fault. All right, let's keep going. If you buy 2 for $5 and you get 1 free. Let's write that down. Buy 2, get 1 free for $5. So isn't that the same as saying you can get 3 for $5? Yep. And we want to know what it costs to buy 12 subs. A couple ways you can do this. Some of y'all are already going 3, 6, 9, 12, and you're going 12, 5, 10, 15, 20. That's fine. You could make this into a proportion. You remember those proportion tables we did? You could do one of those. I mean, you could do, you could do subs and dollars, and you could do 3 subs, $15. So you could just keep going and make a table with this thing. I'll draw a line all the way through. Sorry, that looks like a mess. All right, 6, 9, 12. Isn't that what we want? 12 subs. Oh, why not put 15? That should be $5. Man, I'm trying to get us ripped off. Probably meant to put a dollar sign. All right, so now multiplying by 2, multiply by 3, multiply by 4. So there's a ratio, a proportion table. Ratio tables, whatever you want to call them. Or you could have done 3 for $5. What can we get 12 for? Look at this. 3x equals 60. Dividing by 3x equals 20. So we've come to the conclusion it's going to cost $20 to get 12 subs. Good to go. Sounds expensive. Bob's got 15 marbles. Good for Bob. Bob has, okay, so we've seen these. We know. One side it says Bob's got 15. The other side it describes it into an expression. 3 more than. That's plus 3. Twice the number. 2x. There it is. Okay. Minus 3. Minus 3. Those cancel. 2x equals 12. Divided by 2. Divided by 2. X equals 6. Bam, there it is. Okay, there's day 2. Make sure if you're watching this on the web page, you can do it on YouTube. Coach Buck 37 with the C and the B capitalized also. Hadn't been on TikTok. You might want to go check that out too. Follow me. Thanks.